Imagine a place in the cosmos so powerful, so dense that nothing can escape its grasp. Not even light. The fastest thing in the universe can run away. This is a black hole. It is a true monster of the cosmos, waiting silently in the dark. These objects are not holes in the traditional sense, but rather an immense amount of matter squeezed into an incredibly small space. They are the ultimate cosmic trapdoors, regions of space-time where the known rules of physics are pushed to their absolute limits. The universe is filled with wonders, but black holes might just be the most mysterious and mind-bending of them all, challenging our very understanding of reality itself. Think of them as the universe's great magicians, performing a cosmic disappearing act. They pull in surrounding stars, gas, and dust with a gravitational force that is almost unimaginable. When you look up at the night sky, you see countless stars shining brightly, but scattered among them, invisible to our eyes, are these enigmatic voids. They don't emit light, they consume it. We can only detect them indirectly by observing their powerful influence on the stars and galaxies around them. It's like trying to see a person wearing a completely black suit in a pitch-black room. You only know they are there when they start moving things around. This cosmic ballet between a black hole and its neighbors is a spectacular sight to behold, even if we can only see the effects. We might see a star orbiting what appears to be empty space, moving at incredible speeds. This dance is a telltale sign that an unseen massive partner is leading the way. Or we might witness a stream of superheated gas being siphoned from a nearby star, glowing brightly in X-rays as it spirals toward its doom. These are the cosmic breadcrumbs that lead us to these hidden giants, allowing astronomers to map their locations and study their immense power from a safe distance across the vast expanse of space. So, what are these mysterious objects that play hide and seek with the cosmos? They are the final act in the life of a truly massive star, a dramatic conclusion to a brilliant existence. They are laboratories of extreme physics, where gravity reigns supreme and our most fundamental theories about the universe are put to the ultimate test. They invite us to ask profound questions about space, time, and the very fabric of existence. The journey to understand them is a journey to the edge of knowledge, a quest to uncover the deepest secrets of our universe. Let's embark on that journey together. How does such a cosmic beast come into being? The story begins with a star, but not just any star. We need a truly colossal one, a star many times more massive than our own sun. Throughout its long life, this star shines by fusing elements in its core, creating a massive outward push of energy. This energy fights against the star's own immense gravity, which is constantly trying to crush it inward. For millions of years, this cosmic battle rages on, maintaining a delicate balance that allows the star to burn brightly and steadily in the vast darkness of space, a beacon of light and life. But all stars eventually run out of fuel. For these supermassive stars, the end is not a quiet fade into darkness. It is a spectacular and violent explosion called a supernova. When the fuel in the core is exhausted, the outward push from fusion suddenly stops. Gravity, the relentless force that has been held at bay for eons, finally wins the war. The star's core collapses catastrophically under its own weight in a fraction of a second. This implosion triggers a massive shockwave that blasts the star's outer layers into space, creating one of the most brilliant and energetic events in the entire universe. After the cosmic fireworks of the supernova fade, what remains of the star's core is left behind. If the original star was massive enough, the remaining core will continue to collapse under its own gravity. There is no force left in nature strong enough to stop this collapse. It shrinks smaller and smaller, becoming denser and denser with each passing moment. All of that incredible mass, once spread out across millions of kilometers, is now being squeezed into an infinitesimally small point. This point is where the laws of physics as we know them begin to break down completely. This process forges a black hole. The gravity of this tiny, super-dense object becomes so overwhelmingly powerful that it warps the fabric of space-time around it, creating a deep well from which nothing can escape. A monster is born from the ashes of a brilliant star, a silent testament to the life and death cycle of the cosmos. It is a natural consequence of gravity, the architect of the universe, shaping planets, stars, galaxies, and even these enigmatic objects that challenge our imagination and our science. It's a beautiful, violent, and fundamental process of the universe we live in. Every black hole is surrounded by a boundary, an invisible line in space that marks the ultimate point of no return. Scientists call this boundary the event horizon. It's not a physical surface you could touch or stand on. Instead, it is the threshold where the black hole's gravitational pull becomes so strong that the escape velocity, the speed you need to get away, is greater than the speed of light. Since nothing in the universe can travel faster than light, anything that crosses this line is trapped forever. It is the edge of the known universe, a one-way door to an unknown destination. Imagine you are in a spaceship, cautiously approaching a black hole. From a safe distance, you could orbit it just like we orbit the sun. But as you get closer to the event horizon, strange things begin to happen. Time itself starts to warp. For an observer watching you from far away, your spaceship would appear to slow down as it approaches the edge. It would seem to move slower and slower, getting dimmer and redder, until it looks like it is frozen in time right at the event horizon, eventually fading from view completely. They would never see you actually cross the line. From your perspective inside the spaceship, however, your experience would be quite different. You wouldn't feel anything special at the exact moment you crossed the event horizon. There would be no bump, no sign, no cosmic doorbell ringing to announce your arrival. You would simply float across this invisible boundary without any immediate drama. For you, time would continue to pass normally, but once you are inside, your fate is sealed. No matter how powerful your rockets are, no matter which direction you turn, all paths now lead to one place, the center of the black hole. This is because, inside the event horizon, the black hole's gravity warps space-time so completely that space itself flows inward, like a cosmic waterfall. The direction we call forward in time is now pointed directly toward the center. Trying to escape would be like trying to swim up a waterfall that is flowing faster than you can possibly swim. It is an impossible task. You are now a part of the black hole, on a one-way journey into the heart of the deepest mystery in the cosmos, leaving the familiar universe behind forever. So, what happens after you cross the event horizon? What lies deep inside a black hole? The honest answer is, we don't know for sure. Our current laws of physics, the very tools we use to understand the universe, break down under such extreme conditions. It's like trying to use a regular map to navigate a place where the concepts of north, south, east, and west no longer exist. Our science, as brilliant as it is, has its limits, and the center of a black hole is a place where those limits are starkly revealed. It is a frontier of knowledge we have yet to cross. The most famous theory, born from Einstein's theory of general relativity, suggests that at the very center of a black hole lies a singularity. This is a point of zero volume and infinite density where all the mass of the collapsed star is crushed into an impossibly small space. Here, space-time curvature becomes infinite, and the concepts of time and space as we understand them cease to exist. It is a place where the universe's operating system crashes. The singularity represents a breakdown in our theories, a mathematical point that tells us our story of the cosmos is incomplete. But many physicists are uncomfortable with the idea of a true infinity existing in nature. They believe that a new theory, one that unites gravity with the strange rules of quantum mechanics, is needed to describe what truly happens. This hypothetical theory of quantum gravity might reveal that there is no singularity at all. Some ideas propose that the matter is compressed into an incredibly dense, tiny ball, something like a Planck star, which eventually bounces back. Other, more exotic theories suggest a black hole could be a wormhole, a tunnel through space-time connecting to another part of our universe or even another universe entirely. The ultimate reason we cannot know for sure is that we cannot see inside. The event horizon acts as a perfect cosmic curtain, forever hiding the center from our view. No information, no light, no probe we could ever send can escape from beyond that boundary to report back on what it found. It is the universe's most secure vault, and so the heart of a black hole remains one of science's greatest unsolved mysteries, a tantalizing puzzle that pushes us to dream, to question, and to continue our grand cosmic quest for understanding. What do you think is inside?